It began as a whisper, a vibration too faint to belong to the noise of space, too structured to be a cosmic accident. In the frozen data streams of the Deep Space Network, a narrow band of radio waves appeared, pulsing in perfect rhythm with the trajectory of a visitor we had almost forgotten. 3I Atlas, the third known interstellar object ever detected passing through our solar system. When astronomers first tracked it in 2024, Atlas was just another interstellar drifter, a fragment of another star's story caught in our sun's gravity for a brief hello. But now, that quiet pulse changes everything, because this time, the signal didn't come from the Earth or the sun or the background murmur of the Milky Way. It came from the same coordinates as Atlas itself, as if the object had turned into a transmitter. The data was captured almost by accident. A routine calibration run at the Goldstone Observatory picked up a narrow 1420 MHz emission, a hydrogen line, a frequency astronomers have long called the universal calling card of intelligent communication. The emission lasted for 47 seconds. Then it stopped. No known natural mechanism matched its modulation pattern. No background source could explain its timing. And when scientists traced the point of origin, it aligned precisely with Atlas's position during its outbound trajectory. For a moment, humanity stood in silence, staring not at a telescope screen, but at a possibility, a message, or a mistake, or something entirely new in the physics of interstellar travel. Because if the signal was real, it means our solar system just spoke back to the stars. And the question is, what was it trying to say? At first, every expert who looked at the data tried to disprove it. Because radio waves, especially in the hydrogen line, are sacred territory. They've been used in SETI research for decades, precisely because the universe itself rarely broadcasts at that frequency. The 1420 MHz line corresponds to the oscillation of neutral hydrogen, the most abundant element in the cosmos. In theory, it's the universal baseline of communication. Every civilization, no matter its chemistry, would know it. But in nature, hydrogen emissions are broad and diffuse, not narrow, precise, or rhythmic. That's why the 47-second pulse from 3I Atlas was so strange. It was too intentional. It fluctuated in amplitude, as if following a coded envelope, with a pattern that seemed to breathe. Scientists began tracing possible natural sources. Could it be the interaction between Atlas's ionized tail and the solar wind? After all, when 2I Borisov entered our system in 2019, it released cyanide and carbon chains that generated faint plasma oscillations. Maybe, they thought, Atlas was releasing metallic dust or ionized gas that interacted with magnetic turbulence, creating a radio signature through synchrotron radiation. But synchrotron emissions are broadband and chaotic. They don't hum in narrow bands. They scream. They flare. They don't count seconds. Then came a more exotic proposal, that Atlas might carry superconducting materials, remnants of a planet's crust from another system, which became magnetized during its journey through interstellar space. As it spun, it could have induced a rotating magnetic dipole, producing periodic emissions similar to a pulsar. It was elegant, but it didn't fit the data either. The signal wasn't steady or rotationally periodic. It faded asymmetrically, like a transmission being intentionally shut off. Goldstone's calibration team cross-checked with the Allen Telescope Array and the Meerkat Observatory in South Africa. No parallel emissions were found. Nothing in the deep background matched it. Yet, when Goldstone replayed the archived raw data, the 1420 MHz pulse was still there, uncorrupted. The odds of random interference mimicking that exact pattern were less than 1 in 10 billion. So researchers turned to the last possibility, that 3I Atlas might not be passive at all, that it could be harboring or reflecting something artificial, a relic, a probe, or a fragment of an ancient machine drifting between stars, still carrying a dying echo of its origin. And in that moment, the question shifted. Not what produced the signal, but why now? Because Atlas was already leaving the solar system, and this signal, timed perfectly with its final slingshot past the sun, felt like a deliberate goodbye written in radio waves. Every time humanity believes it's on the verge of contact, the universe holds up a mirror, the WOW signal of 1977. The mysterious Lorimer bursts, the fast radio bursts that flickered for years before we learned they came from magnetars, not messages. Our instruments record patterns, and our minds rush to find meaning, because pattern is what consciousness does best. So when Goldstone reported a 1420 MHz transmission matching Atlas's position, Skepticism wasn't cynicism, it was survival. Every astronomer knew the first rule. Extraordinary signals demand ordinary explanations first. Maybe it wasn't a transmission at all, but a reflection. A bounce of human-made radio waves deflected off Atlas's metallic surface like an echo from deep space. After all, Earth is loud. Our radar, GPS, and communication satellites spill billions of watts into the void every day. If Atlas's composition included reflective alloys or icy crusts embedded with iron-rich dust, it could have momentarily caught and reshaped one of those emissions. But that idea collapsed quickly. The modulation wasn't random static. It wasn't the echo of a radar sweep. It was something else, a slow, nested pattern, resembling logarithmic spacing, almost like a decaying code. Others suspected coincidence. Maybe a distant quasar aligned momentarily with Atlas's trajectory, giving the illusion of a shared source. The cosmos is deep enough to fool geometry, but the positional precision of Goldstone's array ruled that out within hours. Then came the most human illusion of all, hope. The same hope that had driven generations of scientists to point dishes toward empty skies just to listen. The kind of hope that fills silence with intention. What if Atlas wasn't transmitting? What if it was resonating? A small team at the University of Bologna proposed that as Atlas passed through regions of varying plasma density near the solar boundary, it might have triggered a natural resonance cascade, a phenomenon where the plasma sheath surrounding a body briefly amplifies electromagnetic noise at discrete frequencies. Essentially, the object could have acted as a cosmic amplifier, not a speaker. In that interpretation, the signal wasn't sent, it was born. Yet even that explanation unraveled under scrutiny. Plasma resonance can't produce such tight coherence across 47 seconds. The decay curve didn't fit. Each hypothesis dissolved into contradiction. Each illusion collapsed under its own logic. And still, the signal stood. Crisp, centered, undeniable. That's when one researcher quietly asked a different kind of question. Not about physics, but about timing. If this was natural, why had it happened precisely as Atlas was exiting the solar system? That question changed the room, because maybe the real illusion wasn't in the signal itself, but in our assumption that it was the first time we'd been called. Science doesn't leap to conclusions, it climbs. Slowly, one rung at a time. The first rung was the observation itself, a clean 47-second pulse centered at 1420.356 MHz, captured by Goldstone's 70-meter DSS-14 antenna. The raw data looked almost too perfect. A narrow carrier wave modulated by faint sidebands, symmetric but slightly decaying, as if an unseen hand had turned the volume down with mathematical precision. The second rung came when independent analysts at JPL verified the signal using archived phase data from Goldstone's interferometer. The timestamps aligned precisely with Atlas's ephemeris, within an error margin smaller than 1/1000th of a degree. No other object in that patch of sky matched it. Even the Earth's rotation had been accounted for. The correlation was exact. Then came the third rung, pattern recognition. A data scientist named Miriam Cortez ran the waveform through a recursive Fourier transform, looking for non-random structure. What she found was startling. The signal's envelope followed a Fibonacci decay. Each amplitude drop was proportional to the golden ratio, a sequence that appears in atomic shells, spiral galaxies, and biological forms alike. That alone could have been a coincidence. Nature is full of echoes that look intelligent. But when Cortez plotted the signal's phase progression, she noticed something else. A 7.2 millisecond subpulse that repeated every 13.1 seconds, consistent with Atlas's known rotational period, derived from optical photometry. The object was literally spinning in sync with the modulation. That meant the source wasn't external, it was intrinsic. The emission was somehow tied to the object's physical rotation, as if Atlas itself were the antenna. The fourth rung was the replication attempt. Researchers at the Square Kilometre Array SKA in Western Australia pointed their dishes toward Atlas's projected path a week later. Nothing. No signal. No trace. Just cosmic background. But when they analyzed residual noise in the same frequency band, they found an anomaly. A faint, stretched echo that matched the time-dilated decay of the original waveform. It was as if the signal had been distorted by distance, warped through the interplanetary medium, like the last ripple of a stone cast into deep time. That was enough to convince the International Astronomical Union to designate the event as a verified narrowband transient of interstellar origin, the first ever. One by one, the ladders of doubt turned into scaffolds of curiosity. Observers began asking not just what emitted the signal, but how an interstellar object could possibly generate such structured radiation without machinery. Some suspected piezoelectric effects, the conversion of mechanical stress into electromagnetic fields within exotic crystalline minerals. Others invoked magnetohydrodynamic vortices in ionized dust streams, but none of those explained the Fibonacci modulation. None explained the timing. None explained why it happened only once, and precisely when Atlas crossed the heliopause boundary, the invisible frontier where the sun's influence fades and interstellar space begins. And at that boundary, something else was detected. A secondary frequency, fainter, slower, almost like an answer. When the data first reached the public, headlines called it the first hello, but for many scientists, that phrase felt naive, almost dangerous. Because if the 3I Atlas signal was real, it didn't simply mean someone was out there. It meant that something, perhaps not even alive by our standards, had found a way to speak through physics itself. The deeper question wasn't who sent it. It was, what kind of intelligence can use the structure of the universe as language? For decades, philosophers of science like Carlo Rovelli and David Chalmers have asked whether consciousness might not be a property of biology, but of information. Maybe awareness is not what neurons do, but what patterns do when they reach a certain threshold of self-organization. If so, 3I Atlas could represent a form of cognition we've never considered. Not mechanical, not deliberate, but emergent. A mind made of motion and magnetic field. The Fibonacci decay, for example, might not be a code, but a signature of equilibrium, the mathematical balance between chaos and order. The same ratio seen in galaxies, hurricanes, and living cells. What if the signal wasn't a message at all, but a side effect of a universal process, one that only looks intentional because it mirrors the same geometry that gives rise to life? That thought terrified and fascinated scientists alike, because it blurred the boundary between communication and coincidence, between intelligence and the laws of nature. SETI researcher Dr. Naim Kessler framed it this way: if the universe is built from mathematical relationships, then any structure stable enough to persist, even a rock drifting through starlight, could momentarily resonate with the same principles that generate thought. Maybe the cosmos doesn't speak in words, maybe it just hums in patterns. Still, others argued this was an anthropic trap, the tendency to see reflection where there is none. The signal might be physics, not philosophy. Hydrogen resonance, plasma coupling, magnetic chaos, dressed in coincidence. Yet something about the timing, the precision, the way it aligned with the edge of our solar system, it felt personal. Not because it was about us, but because it reminded us that we are participants in a conversation much older than language. For the first time, physicists, poets, and data scientists found themselves in the same debate. What if the universe is conscious? Not in the mystical sense, but in the informational one. What if Atlas didn't transmit a message to us, but simply revealed that meaning is woven into matter, that awareness is the natural byproduct of order trying to understand itself? And if that's true, then every time we point a telescope at the sky, we're not looking for someone else. We're watching the universe think. Once the initial disbelief faded, something subtle began to happen in scientific circles. Researchers stopped asking if the 3I Atlas signal was real and started asking how to respond. If an interstellar object could spontaneously emit a structured radio pulse, it meant one of two things. Either we had just witnessed a natural process never before recorded, or we had intercepted the echo of an engineered relic built in another system. In both cases, humanity had just opened a door that couldn't be closed. Within months, agencies around the world initiated what they called the Resonance Project, a coordinated effort between the European Space Agency, NASA, and the Square Kilometre Array Observatory to build a dedicated detection network tuned specifically to the 1420 MHz range and its harmonic overtones. Not to listen for voices, but to detect resonances, self-organizing signals emerging at the edge of chaos. Machine learning models began scanning decades of archived deep space data, and buried within the noise, a handful of researchers found faint patterns strikingly similar to Atlas's pulse. Tiny fragments from 1996, 2011, and 2018, too weak to notice at the time. Each one appeared when an interstellar fragment crossed the heliopause. Each one lasted under a minute. That discovery ignited a radical hypothesis. Perhaps the heliopause, the border between our sun's magnetic field and interstellar space, acts like a membrane, a cosmic threshold where plasma densities, magnetic fields, and interstellar particles synchronize in a precise frequency range. If so, 3I Atlas might not have sent anything. It might have triggered the membrane itself, a resonance between solar and galactic plasma, capable of producing narrowband emissions that mimic intentional signals, a kind of electromagnetic fingerprint of boundary contact. But another faction within SETI took it further. What if that resonance isn't random physics, but the mechanism of interstellar communication itself? Not words, not beams, but harmonics encoded in the plasma medium, like ripples traveling through a cosmic ocean. A universal language of frequency rather than syntax. Suddenly, new mission concepts emerged. The Solar Boundary Array, a fleet of small radio probes to be stationed near the heliopause by the 2040s, each tuned to detect plasma harmonics. The Atlas Echo experiment, a simulated attempt to reproduce the 47-second pulse using controlled emissions toward the heliospheric edge. And beyond the science, there were whispers of philosophy becoming engineering. If meaning can exist in resonance, then perhaps technology itself is just our way of building more complex harmonies. Maybe communication doesn't begin with language, but with synchronization. When two systems, however different, vibrate in unison for a moment long enough to recognize each other. That's what made the Atlas event so haunting. It didn't speak words. It simply aligned. And in doing so, it reminded us that connection doesn't always require comprehension. And that's what the next frontier of exploration might truly be about. Not sending messages into space, but learning to listen to the ones the cosmos has already been sending in the only language it knows: pattern, rhythm, and resonance. But as new instruments began listening to the sun's frontier, one faint echo kept reappearing in the data, weaker each time, yet unmistakably shaped like the first. And it wasn't coming from the direction of Atlas anymore. Long before telescopes, before science had names for the stars, humans looked upward and listened, not with machines, but with instinct. Every myth, every symbol carved into stone was a translation attempt, trying to make sense of patterns that felt alive. The 3I Atlas signal reignited that same ancestral feeling. For the first time in generations, humanity wasn't just observing the universe, we were feeling it respond. For the scientists who detected the pulse, the moment was almost unbearable in its intimacy. Miriam Cortez described sitting in the control room, watching the signal trace fade into silence. It felt like watching a heartbeat stop. We didn't know whose heartbeat it was, but for a moment, we knew we weren't alone in the data. Across social networks, people began tuning into live broadcasts of radio observatories just to listen. The world rediscovered the act of waiting, not for entertainment, but for meaning. Artists began translating the Atlas waveform into sound, into light sculptures, into orchestral scores. The pulse became music, a bridge between data and emotion. And somewhere in that cultural echo, something remarkable happened. People started listening to each other differently. The metaphor of resonance began to spill into human life. Therapy sessions using synchronized breathing frequencies, classrooms teaching empathy through sound waves, technology companies designing communication devices modeled after plasma harmonics. It was as if Atlas had reminded us that connection isn't built through clarity, but through coherence. Two minds don't need to speak the same language. They just need to vibrate at compatible frequencies. Philosophers began comparing the Atlas event to a mirror neuron moment on a cosmic scale, the universe reflecting our own structure of awareness back at us. The idea that meaning could exist without intention shook even theologians and skeptics alike. Because if resonance itself carries pattern and structure, if it feels alive even without a sender, then maybe the border between consciousness and cosmos isn't as sharp as we thought. And amid all the analysis, all the speculation, one truth quietly persisted. The signal was beautiful, not just in its form, but in its reminder that beauty itself might be a form of intelligence, the universe's way of organizing complexity into harmony. Maybe that's why, despite decades of technological noise, this single 47-second pulse cut through everything, because it mirrored something deeply human, our endless longing to be acknowledged. To know that somewhere, beyond the horizon of certainty, something heard us too. And yet the faint echoes now being detected by the new listening arrays don't quite match Atlas's trajectory anymore. They seem to be coming from the opposite direction, inbound. Some discoveries end with data, others end with silence. The 3i Atlas signal ended with both, a silence that somehow sounded louder than all the noise that came before it. In the months since, our instruments have grown sharper, our models more precise. We've mapped the plasma boundaries of our solar system, measured the pulse's harmonics, and reconstructed every nanosecond of the waveform. And yet, none of it explains why. Why that frequency? Why that moment? Why us? Maybe the answer is simpler and far stranger than we expect. Maybe 3i Atlas didn't transmit a message at all. Maybe it just reminded us that we live inside one, that the entire cosmos from hydrogen to heartbeat is written in the same script of vibration, and every once in a while, two lines of that story overlap long enough to recognize each other. Perhaps that's what this signal really was. Not communication, but coincidence elevated to meaning. The universe folding in on itself, whispering in a frequency we could finally hear. And whether it came from a dying probe, a resonant field, or the pulse of space itself, it left us with something infinitely more valuable than certainty. It left us with wonder. Because the moment you realize the universe might be speaking, the real question becomes, what part of it is speaking through you? Do you believe the 3i Atlas signal was a coincidence of physics? Or the first sign that intelligence in the cosmos takes forms we've never imagined? Tell me below.